Thank you. Thank you very much. So I'm going to teach you how to learn again. I'm sure that all of you think already that you know how to learn, but you're wrong. It's okay, though. I'm going to fix it. Before we get started here, my name is Jonan. I go by the Jonan Show on the internet. Can you hear me okay in the mic here? Yeah, we're good. I go by the Jonan Show on the internet. It's not so much Jonah, as in the Jonah and the whale story. It was going to be Jonah, and then my mother wisely, right as I was born, decided that I would be called Jonah the whale. She knew I would be huge. I've stood in rooms at family reunions where I'm the smallest guy in a room of 60 guys. Like, we have 7-foot-tall basketball players in my family. So she changed my name to Jonah. I am not Jonah. I'm also not Jonas, as in the guy who carries the wind in a Weezer song. This is an old people joke. Not a lot of people know that song, but people used to sing that to me. My name is Jonan, I'm carrying the wind. That's not me either. I'm in fact Jonan with an N, like Conan, but spelled with a J. This is Jonan the Barbarian, courtesy of my friend Josh. So, quick disclaimer. This is a neuroscientist, and this is a neuroscientist meeting the Dalai Lama. And this is me. And this is me meeting the Dalai Lama, which I have not done yet, right? Yet. I'm not a neuroscientist, right? If we consume enough beer, it's possible that I will appear a neuroscientist. I am not a neuroscientist. I want you to take everything I say with a grain of salt, please. But these are some things that I think are mostly true, and I think they're mostly true because I've read a lot about them. And I can send you to some resources to learn more about it so that maybe you believe this kind of thing too. But as a developer, I'm someone who has a pretty high bar. Pop science is not terribly appealing to me, right? Taking a study and then talking about it as if it means more than it does. So I read a lot of studies about this kind of thing. And I think that most of these things ring true to me personally, intuitively. And so I'm going to convey them to you today. But please do not confuse me with a neuroscientist. So I want everyone who is normal to raise your hands, please. All the normal? Oh, it's normal. We got one. This is the first time I've ever been to talk and I had someone raise their hands for normal. This is good, right? I think that most of us, we feel a little bit more like this. Has anyone ever heard of kintsugi? This is the Japanese approach. This is an old bowl that broke, right? In America, we throw old things away immediately, take them to Goodwill and let other people have them. And you know, honestly, the Japanese much prefer new things as well. The equivalent of Goodwill in Japan is very, very cheap. Right? You can buy some really nice things if you go and find a thrift shop in Japan. But this is an old art form called kintsugi, whereby you repurpose old things with golden paint. You rebuild the bowl. So for those of us who are not normal, I don't think anyone really is, fundamentally, right? Just as with anything, we all exist on a spectrum, right? And that spectrum is beautiful for all of its imperfection, right? So try and embrace that mindset as we go forward. Another thing that I want to do, I'm going to actually just summarize the whole point of my talk right now, and that is that I want you to love yourselves, right? It's a very simple thing to do. In fact, I'm going to do it with you real quick in 10 seconds, okay? I want you to think about something that, that loves you, your dog, your mom, anyone who loves you. Think about the people that love you, right? When you think about that love, some very physical changes happen in your body. Probably you get like warmer here in your midsection, right? Your brain kind of opens up a little bit. A lot of the pain receptors in your body are a little bit harder to feel when you're feeling love. So I'm serious right now, just think real hard about all of the people in the world that love you, myself included. I love all of you. I love every person I meet, right? I really want you to live a happy, healthy life, and this is exactly how you do it. Feel that love, feel that compassion for yourself right now. I know this sounds metaphysical and hippy-dippy, right? I grew up in Ashland, Oregon. I know all about hippies, right? But this is a real thing. There's a lot of science to back this up, right? That intention matters very seriously. So feel that love, and then we're going to do a quick breathing exercise, 10 seconds long, okay? For 4 of those seconds, we're breathing in a slow, even breath. The next 4, we're going to breathe out in a slow, even breath. And the last 2, we're just going to settle there for a second, okay? So we're just going to breathe in all together. And we're done. And that is how you love yourself. Feel that love, hold it, Breathe slowly and evenly. This, right now, what we just did, it changed your heart rate. It didn't necessarily lower your heart rate, maybe it did. What it did is it changed your HRV, your heart rate variance, right? The difference between one heartbeat to the next. If you do that for a while, your heart rate variance changes significantly, right? Normally, your heart is beating faster or slower in any given moment, speeding up and slowing down. And when you breathe, you hold that intention, you level that out, and your body likes that a lot. Your body likes to receive consistent resources all of the time. And we're actually not very good at giving our body consistent resources. So that's it. That's the whole talk. I just gave you the secret to happiness, literally the secret to happiness. I'm going to elaborate a little bit since we're here. And given that I have about 100 slides, I think that should take us about 3 hours at this rate. So I'll go a little faster. Let's talk about brains. We all have them, right? We carry them around on our body robots, right? But specifically, I want to talk about the distinction between the brain and the mind, right? The brain, I want you to think about as the scaffold, right? This is the framing, the architecture that you were born with. Genetically, you got a brain. Some people got different brains than others. That's the end of the determinism there, right? You got a scaffold when you were born, genetically, and you built your mind on top of it. You own your mind. Your mind is different than your brain, okay? Your awareness, your consciousness, this is a thing that can be affected, right? Your brain probably not so much. Actually, it can. Your brain changes a lot. Up until 1990, we didn't have fMRI technology. Has anyone heard of that before? This is functional magnetic resonance imaging. We used to be able to take MRIs of people's brains and we could get a static point in time. And then we got fMRIs. And fMRIs are able to scan your brain as things happen. That changed the game fundamentally for neuroscience. Neuroscience since 1990 has exploded as a result of this technology, right? We now know that brains change. When I got into middle school as a kid, right, we were told that our brains were just static. That was it. They expected that nerve cells didn't really grow or change, right? We knew that the spinal cord would be severed and not regrow, and therefore nerve cells were just not a thing that we regrow. Turns out that spinal cord is about the only place that they don't regrow. And now there's some new science suggesting that there are changes we can make to the body that will actually make that untrue, right? So that's your brain, and it's distinct from your mind. But a lot of the confusion that exists there is from ancient Greece. Mind-body dualism is the concept. There's a drawing by Descartes that is supposed to describe mind-body dualism, and I don't really see it. I'm not sure I understand what Descartes was going for here. But this was all introduced by Plato back in the day. Plato was a dualist, right? Mind-body dualism basically says that your mind and your body are separate things, right? It's that thing I was just talking about how your brain and your mind, they exist here, and they're carried around by this robot, this body that just like inconsequentially is here, right? That's not true, as it turns out. In fact, that picture of a brain that I just showed, you may have noticed that the spinal cord was severed off of that, right? The entire remainder of your nervous system is plugged right into that thing, right? That's your brain in its entirety. Your entire nervous system is built out of neurons, the same stuff. Plato taught this to Aristotle. Aristotle and Plato taught this to Descartes. And then we have dualism, right? Mind-body dualism. This is the autonomic nervous system. It's part of your peripheral nervous system is how we describe it. Anything outside of the brain we describe as your peripheral nervous system. And this way of thinking, in my not so humble opinion, has led us to this dichotomy, which is false, right? Neurons change and grow. You can change and grow neurons in your brain. You can change and grow neurons elsewhere in your nervous system. When you're learning how to do a thing, anything, catching a ball, like running faster, those are things that you learn in your brain, but you also learn them in your body, right? We learn all over. So today we're going to think about the nervous system in its entirety as integrated with the body. I'm a monist, right? Well, why'd you use a dualist symbol? You've got the yin-yang up there. That's a dualist. No, it isn't. And it's not a yin-yang. It's a yin-yang. I Googled. I take my cultural appropriation very seriously. I'm a monist, right? This is a symbol, actually, of monism. What this is about the wholeness of being, right? Knowing the darkness by the light, that all of our parts fit together to make who we are, right? I'm going to give you an example. Maybe you played with like Where's Waldo books as a kid. I want you to find the vagus nerve here in this picture. Anybody want to point to the vagus nerve? Vagus nerve is one of the primary nerves that runs down out of your brain into your autonomic nervous system. Vagus nerve. No? There it is. There's the vagus nerve. Right there. Running down and, oh wait, also here. Oh, and there's a little bit more of it. Yeah. It's actually woven into the tissues here. This is your sinoatrial node. This is your natural pacemaker. It's on your heart, right? And if you look very closely at the tissues, you realize that it's not that your heart is here and a nerve just pokes it to make it beat, right? Your sinoatrial node is in part composed of your vagus nerve, right? So think about the integrated nature of your nervous system again. Try not to think of this as a separate thing from your body. It is your body, right? Let's talk about neurons. This is an actual picture of a neuron. We can take actual pictures of neurons now. The future is amazing. It's kind of complicated, right? We all probably took some biology classes when we were kids, and we learned about axons and dendrites. Anyone know the difference between an axon and a dendrite? Yeah, so we got some dendrites here going off is the plan. Yeah, pretty close. Axon's actually kind of the same thing. All the things that come out of the cell body, right? A cell is said to have one axon and many dendrites. The dendrites being the input along similar channels as axons, right? Many sources of input, a single source of output, but a single source of branching output, right? Actually, an axon branches many times. There's no reason for the cell body necessarily to have many different arms coming off if it can just have one arm coming off that then branches later to multiple cells, right? This is kind of another confusion, I think, about the nervous system. You have many sources of input from all of your neurons in your entire body, and you have many sources of output from all of your neurons, including sometimes circular input-output, right? So this is what a neuron looks like. These are all the channels with which we communicate. Those axons and dendrites, when they end, we have a synapse, right? Synapse is a chemical transmission. Inside of a cell, we use electricity to send signals. So the chemical part of that transaction is a little bit slower, but we call this electrochemical energy, right? That your nervous system is just sending energy and information through your body all the time, okay? And it doesn't really matter to us if it's electrical or it's chemical. It's just energy and information moving through your body. Right now, as you're hearing my voice, the little hammer banging on a bone in your ear that's making some pattern of noise. I mean, literal noise. If we're talking about like an electrical signal, it's just static kind of thing, right? And those are being transmitted down into your brain. And you're hearing those according to your perceptions of what I'm saying. And the words that I'm saying are being interpreted by you real time. And I can't actually know what those words mean to you, right? Those are different for all of us. So this is your spinal cord here, again with the picture that includes a butt in it from the autonomic nervous system. I'm sorry about the butt. I'll crop the butt off in the future. Your spinal cord. So we're going to walk through. I was talking about those axons just now, right? Does anybody know where the longest cell in your body, the longest axon in your body? It's your sciatic nerve. Runs from here. Someone say, my sciatica, right? It's from here down to your toe. You've got a single axon. It's a protuberance off of one cell. Runs all the way down to the tip of your toe. So let's pretend we stub our toe, right? A signal's initiated from the tip of my toe up here and up my spinal cord, right? That signal is electrical all the way up to here, and then maybe it's chemical and it goes up to my spinal cord. Either way, we don't care at this point, right? We're just talking about energy and information flow within the body. Where does it go then next? Comes up into our brain to the thalamus. So the thalamus controls the autonomic nervous system maybe. We don't really know what anything in the brain controls. It's not that clear cut. This is not how our study of the brain has gone. We're doing our best to map the different regions of the brain and figure out what's going on in all of the different places. But I was equating this earlier to an alien civilization. This is a thing I stole from Jeff Watkins, but let's say sometime in the future, humans are long gone, alien civilization shows up on Earth. They're trying to figure out what the highways and roads are for, right? They're looking around at all these highways and roads, and they're taking very careful notes, and they're writing down where all the highway signs are, right? I lived on a road in Ashland that was very curvy, and so they're noting all of the curves of this road, right? Remembering all of the exact details, and eventually, one of them realizes that humans can't teleport. oh, they had to build these machines that they burned dinosaurs in, and then they drove around, and that's how they got from place to place. Well, now suddenly all of the highways and roads make sense, and all of the details are kind of irrelevant, right? I'm going to go more into that later, okay? But right now, let's just consider this. The signals come up here. Signal hits my thalamus. This is usually where all of the motor control goes. We know that the thalamus is going to fire again if I try to like move my arm up. Right now, I'm using my thalamus a lot as I'm moving my body, okay? My heart beating is using my thalamus. So the signal comes up for this to my thalamus, comes up here into the limbic system, right? The limbic system has many components. We're going to walk through a couple of them here. This red part here is your limbic system. So limbic system includes the hippocampus. Hippocampus looks a little bit like a seahorse, commonly compared to a seahorse. I think it's interesting. And it's actually two seahorses, right? And it's two conjoined seahorses. They meet here and they kind of wrap around towards the front of your brain, right? Headed up towards the prefrontal cortex, right? It's your hippocampus. You've got your amygdala in there, this little red dot, little almond-shaped bit that's part of your limbic system. That's where fear lives. Everything is very scary for humans. Generally, we're pretty fear-motivated. We like to think of ourselves as these like grand explorers, right? We set out and we spread all over the earth, but mostly we were fleeing from oppression in all cases, right? Things were bad, so we left and we found better things. The human brain is designed to head towards certainty. That's what you want. Uncertainty is kind of unpleasant for us. If I sing to you a little song, da-na-na-na, you probably know what the next note was going to be, right? You're like, oh, that was the alphabet song, or that was Twinkle, Twinkle, Little Star, right? You're guessing what the next note is because your brain is constantly predicting what you're going to see. And when your brain doesn't see what it expects to see, doesn't like it, right? And it starts to learn, but this is kind of what I consider to be the fundamental motivator of human beings, is fear, unfortunately, right? It's the amygdala. And then it comes up into your insular cortex, I guess here, down below the neocortex. And the insula was really poorly understood. You kind of have to cut away the brain to get to it, and it kind of looks like the rest. And 20 years ago, if you tried to write a paper at university, you're a neuroscience graduate student, and you're like, I'm going to write a paper on the insula, people would have thought you were very silly. Like, are you just choosing the most obscure part for no reason? Like, nobody cares about the insula. There's no research on it, right? We don't really understand. Now we understand a little bit more about the insula. Turns out, the insula is kind of involved with, everything. It's firing all the time for a lot of reasons. There is reason to believe that the insula is actually how we pay attention to things, how we focus on things. It's maybe where awareness lives. And just like all of neuroscience, a big maybe there, right? But it's used in all kinds of things like pain reception, in this case, or social engagement, or emotion and empathy. It's used all over the place. We don't really know what this thing does, but it does appear to be used in all sorts of things. So maybe it's awareness, attentional focus, right? That's the insula. And during this entire process, we were firing neurons, right? We were firing neurons all the way up. And there's an interesting property of neurons that is when they fire, they wire. Neurons that fire together wire together. Any book you read on neuroscience is probably going to include this phrase, very popular phrase in neuroscience, because firing neurons makes them stronger. It makes that signal more likely to come again. If I say to you the word doctor, and then I say nurse, it's easier for you to hear nurse after I say doctor, or vice versa, because they're related in your brain. These are two cases. I say nurse, and then I say bread. That was harder, right? Maybe you're more used to big O complexity of things. We'll just call that one more complex, okay? If going from doctor to nurse is one cycle, then going from doctor to bread is 2 cycles, okay? Twice as hard, right? This is priming. And this is the same thing that makes our memories form and makes it easier for us to catch balls over time, right? This eventually turns into memory, permanent physical changes. Everything that you know is a permanent physical change that has been stored in the neurons of your body. It's not just an electrical signal that's floating in a loop. This is a confusing idea to us, right? Especially as developers, we're like, well, where's the hard drive? Well, there's not a hard drive. It's an entire computer, which is not really, without a hard drive. And yet it stores information. Well, then it must all be in memory, in RAM. No, not really. No, it's actually kind of quite different from a computer architecture, and I'll dig into that a little bit. But let's talk about the neocortex and how it differs from a computer. So we come up here, we've got our pain signal all the way up through the insula into the neocortex. And this is probably where cognition happens, right? The neocortex and intelligence, right? What even is intelligence? So this is kind of a hard question to answer. Does anyone have an answer to that? Like, what is intelligent? I have a guess, okay? Does anyone know who this is? Mr. Heisman? It's the Heisman pose from football. I was a football player. I was not an awesome football player, but I did it. I'm glad I did. And this is a very famous pose. People who win the Heisman Trophy get a little trophy just like this. So I look at intelligence the same way I look at proprioception. Proprioception is your awareness of your body, where it is in space in any given moment. You ever see those Vibram 5-finger shoes, right? They were real creepy and popular for a while. I loved them. They were great. I wish they'd become socially acceptable because I would still be wearing those things. They were really comfortable and they improved your proprioception supposedly, right? Your awareness of your surroundings. This is what athletes are very good at, proprioception. They know where their bodies are and they know how to move their bodies from point to point. This is the kind of thing that they're trained to do. So if proprioception is your awareness of where you are in space, intelligence would be your awareness where you are in problem space, right? Developers, I think, on the whole, are pretty intelligent people. We're people who are good at navigating problem space. We're able to hold a lot in our minds and work with it, right? That's how I define intelligence. I want to make it very clear that intelligence, to me, is not defined by your brain at birth. Again, the brain is the scaffold, right? These are the cells you were born with, this genetic information that defines how things. Some people have, very serious deficiencies in that area when they're born, right? But it doesn't necessarily limit them from being intelligent, right? We have plenty of cases where intelligence is totally unrelated to the actual group that goes on in your brain. And in cases where people are blind, for example, right? Parts of the brain, parts of the cortex are repurposed to read Braille. The visual cortex, we don't need that because we can't see, right? They're going to use that to read. They still have the other reading part of their brain, but your neocortex is all pretty well used. We have this theory that 90% of the brain goes unused, and if you can tap into your hidden potential, no, none of that's really true. Brains mostly like to be used. They get repurposed, and you can repurpose parts of your brains to become more intelligent, in my opinion. But we'll dig into how that works. So this is Jeff Hawkins. It's the guy who invented the Palm Pilot. Anyone ever heard of him? Really interesting man, right? He invented the Palm Pilot. Now, why is he here? He also wrote a book called On Intelligence in 2004. And it was about building intelligent machines. Because Jeff saw where artificial intelligence and machine learning were headed, and he didn't like it. And long before that, Mr. Hawkins went off to school and he tried to apply into neuroscience programs. He became a programmer and he worked for a little while as a programmer, and he was like, we had an issue of Scientific American about the brain. He became very passionate about the brain and how it functioned. He wanted to build intelligent machines, genuinely intelligent machines that emulated the way the neocortex functioned. And in 2004, he was very disappointed in all of the approaches that we were coming up with, because we were coming up with a pretty simplistic approach. Computers, they take input, they do a calculation, and then they have an output, right? And this is how we were trying to build machines, as though the brain did that, right? The brain doesn't do that. The brain operates very differently. According to Mr. Watkins, and I believe him, or Mr. Hawkins, I keep saying Watkins, don't I? I'm sorry, Jeff Hawkins. Jeff Hawkins wanted to come up with an algorithm to describe how the brains work. And I actually kind of believe it, right? And this is not a thing that is well proven yet. There's not a whole lot in neuroscience that is well proven yet. So take this with a hefty grain of salt, but it seems pretty intuitive to me. I'm going to try and describe it to you. It's much more complex. I recommend that you read this book because we don't have time to dig into detail of how it works. I think we're only on slide like 10 out of 100. We're going to be here a long time. So your brain is a napkin. That's what Jeff says. It's pretty easy to understand, right? Done. Not really. So he's describing your neocortex. Your neocortex, if you were to take 6 business cards and hold them together, your neocortex is about that thick, right? And this is the wrinkly part of the brain that we always see. It's your neocortex on the outside of the top of your brain, right? It's actually about the size of a dinner napkin. You hold up a dinner napkin, it's like this big, right? When you stretch it out and flatten it. And really interesting thing happened in human evolution that caused us to have a bigger neocortex than we can really fit in our skulls, and that forced it to wrinkle up. And our neocortex is much wrinklier than those of species we consider to be less intelligent than us, right? And maybe that's why, is that we had this evolutionary advantage where our napkin scrunched up faster and better than anybody else's napkin. We started to use our thumbs right, and we took over the planet, right? And we started eating all the rest of them with their inferior napkins. Right? So he describes the neocortex as a napkin with 6 layers, okay? 6 business cards, 6 layers of neocortex. Now, in reality, the neocortex is a football stadium full of spaghetti, okay? It's not actually layered quite like this, but there are layers as far as processing goes. So conceptually, it's much easier to think of this as layers, okay? You have layer 6, where your sensory input comes in, going up to layer 1, where you remember, or vice versa, I believe. I think it's like 1 to 6, doesn't matter. The point is you have a memory and you have an input, and they meet in the middle there, okay? And at the same time as you have a memory of what you're expecting to happen, your new input, normally what you think is going to happen affects how you act more than the individual input. And this is where bias comes from. It's where racism and sexism come from. You think you know, right? You meet a new dog, but you've already met 20 dogs, and 15 of them bit you. How likely are you to walk up and pet that dog, right? Zen Buddhists talk about this a lot, about how important it is to walk up that dog and treat that dog as a new dog, brand new dog, because it is a new dog. You don't actually know anything about that dog. You don't know anything about that person. But it's natural. Brains head towards certainty. It's natural for us to make predictions. I was raised in a mostly white town full of white people. We wore a lot of Love See No Color shirts in Ashland, okay? We were very open-minded for a bunch of white folk, but we were mostly white. And this means that my brain is pretty well wired at this point to recognize that in a crowd of white people, there are some people that are not white, right? But I get to choose what I do with that information. Intention matters a lot, right? I can apply all of these stereotypes and biases that I've collected over time, or I can just not. It's a real thing you can do. You can choose to do with your brain. So that's our napkin on our brain here. And he talks about developing a neocortical algorithm. He wants to describe how the brain works. One of the examples he gives is this saccade process. Your eyes, when you're looking at a thing, looking at me right now, they're moving several times a second, right? Mostly unaware to you. They're processing information, and again, this is just a signal. It's quite noisy. It's just pixels firing in your rods, right? Our brain is really good at filling in the blanks. There's a bunch of missing data in that stream. We just fill it in. We just make it up. But our eyes are moving constantly. So when you're seeing me in any microsecond, you're seeing me from a new angle. Your eyes are constantly moving and let you know that I have a face, right? You know that I have arms and I am moving them. But the visual input is always different. Every time you see me again, from now until the end of time, you will have new information, and somehow you make sense of that. So how is that even possible? Jeff's memory prediction framework kind of tells us how, right? This is Ruby, look, actual code in the neuroscience talk. This is the last of it. This is all the code that you get, okay? He describes it as sets, right? From mathematics, they're unordered. There's a chunk of information, various components. We know that faces have eyes and ears, right? It's incomplete, but even if I am partially occluded, I'm hiding behind a wall, and you see an eye and an ear, your brain will fill in the face. It'll assume that I have a face, whatever I am, right? We have partial sets that point to other sets in the brain and are interwoven. It's kind of a hard concept to describe in programming, but imagine that like I points to every set that also includes I, but not even I, like whatever comes after I. We're headed towards face, okay? But I can go in a lot of directions, and ear can go in a lot of directions. They're connected. They give it like a hash key, right? Pointing off to another set. We have sets pointing to sets, and all of their individual components, right? And remember that when we're firing these patterns, they're wiring together, and they're becoming more likely to fire again, okay? your brain is a pattern recognition engine. It is possible that you were born, well, probably before birth you started to form memories. They've proven that you can have memories of music in utero, right? But in the beginning, you have a pile of clay, and patterns start to appear on it. And your brain starts to make sense of those patterns and to match them in order to make predictions. Maybe that's what the neocortex is. It's pattern recognition, right? We're finding patterns, we're making predictions about those patterns, we're getting upset when they are not what we predict, right? That's maybe what the neocortex does. Maybe that's what the brain does. Maybe that's what neurons do in their entirety. They make up patterns based on the input that they receive from all of your senses. And then they use those patterns to make predictions that help keep you alive. And this is probably why we head towards certainty, right? If you got a cave with a nice fire and a good source of food, why are you going to go exploring? That's ridiculous. From an evolutionary biology perspective, that's a real poor choice. You're like, wow, I'm real safe and happy. I'm going to wander off into the wilderness and see if I find any lions. That's a ridiculous notion. That's not what humans do, right? We're curious creatures because we head towards certainty. That's what makes us curious. We want to know the answer because we want to be able to make effective predictions. This is Jeff's hypothesis on how this works, right? So at the top of this hierarchical representation of patterns, we have invariant representations. And this is how you will know that it's still me when you see me in the future. You, having met me, again, my name is Jonan, not Jonah or Jonas. Having met me, you will always have a neuron in your brain that fires, unless you totally forget me, which is possible, and I'll forgive you. Just come up and get my name again. It's totally fine, right? You will always have a neuron that fires. People who know who Bill Clinton is at all, they've seen him on the news, they have a neuron that fires when they see Bill Clinton. It's a neuron for that invariant representation of what is Bill Clinton, right? We have something like 100 billion neurons. Billion is a big, big number with a B. And we don't actually have to only have 100 billion ideas, right? Because we're storing things as patterns. And we can rearrange those patterns and we can attach them to each other in different ways. And this is why, even though a brain is significantly slower than a computer, it beats a computer every time, right? If you ask a human to find a face and a computer to find a face, even our best algorithms today get crushed, right? But the computer's like 5,000 times faster than your brain meat. How is the brain doing that? It's with these sets, right? Is this a face? Well, yeah, it's a face, but it's also a dog, right? It's a dog's face, but it has eyes and ears and a nose and a mouth. We recognize that as a face and also as a dog. And hopefully a different dog. Just because a boxer bit you one time, be nice to this dog. He probably loves you. So names are important, right? Those are the things that I'm talking about here at the top of this hierarchy. Those are the names. Jeff calls them names, okay? The thing, whatever it is, that represents dog or face or Jonah, this is now permanently burned into your brain. Because when neurons fire together, they wire together. And if you see this image every morning, you'll get to know it better. And it'll be much easier for you to remember this thing. You're training your brain with everything you do. So think about what that means about me stubbing my toe. If I stub my toe and I'm like, God, you idiot, you walked into the table again, my brain learns that. And my brain is not necessarily, I know I'm not an idiot, right? I think I'm smart, but my brain doesn't know that. Your brain doesn't know the difference between true or false. This is what all of these self-help gurus have been telling us for years. It's actually true. We're starting to find neuroscience that matches up with all of this metaphysical nonsense, like positive self-talk matters, and it really, really does. If you call yourself dumb or an idiot for any reason, you are learning that. Those neurons are becoming more likely to fire without context. You're not recording the context with that interaction. You're just putting a new set in your brain. Be very careful about the sets that you install in your brain. Feedback. So I talked earlier about the neurons all being connected to each other and they loop around in circles and so on, right? These little networks of neurons, they fire back into each other. So unlike neural networks today, when we're looking at, or neural networks are like the new thing in artificial intelligence, right? This is like the evolution of artificial intelligence. Neural network has an input and a little black box in the middle and an output, okay? And in the middle are digital neurons, right? You know, a few layers, 3 or 10 or 100, maybe, I don't know. Neural networks can get pretty complex inside. We put an input in over and over and over again, and we train the system, and then we get an output. So say I'm trying to like recognize a photo of a thumbs up or a thumbs down. So I feed it a whole bunch of thumbs up, and I'm like, this is a thumbs up. Feed it a whole bunch of thumbs down, and this is a thumbs down. And then I send it some more pictures it didn't know about ahead of time. I'm like, is it a thumbs up or a thumbs down? And it can answer that thing, right? But that's not how our brains work, because answering that thing doesn't include the part where your brain is learning all of the time. Your brain never stops being trained. Some neural networks, more modern neural networks, are still doing this thing, but they're still doing it in a pretty simple way compared to how your brain does it. Your brain, a single neuron in your brain could have 10,000 connections to other neurons. These sets are huge and complex. Jeff Hawkins has a company now called Trumenta that is using this algorithm to write software. They're hiring Pythonistas. If you're a Python programmer, oh, and you have a PhD in neuroscience, they'd be interested in talking to you. Yeah, I would be applying for that. I would learn Python, but the PhD thing, I don't know if I have time in my life for the PhD. But Jeff, if you ever see this talk, bro, hire me. I'm your guy. I'm so passionate about this, right? Feedback is really important. And this is how habits are formed. This is how you brush your teeth in the morning without thinking about it. Do any of you like concentrate real hard on brushing your teeth? Probably not. But you probably do it according to a system, and it's the same system you always do. I have one of those, my sister's a dentist, so I have one of the electric Sonicare toothbrushes recommended by dentists worldwide, right? And I do the left top and the right top and the bottom left and the bottom right, and it's just the same system. If I don't think about it, I just do the same thing every time. But I've taken to thinking about it. I try to live my life, all of my life, with intention. I do weird things like put my pants on with the odd leg, right? I brush my teeth with my odd hand. When I'm walking, I try to do like Ministry of Silly Walks stuff, right? And what I'm trying to do is to chop up my habits in my brain. I'm trying to mix things up a little bit, because this is the essence of learning, and this is how you break bad habits in your brain. So you're thinking, well, Jonan, what you've just described is basically like predeterminism, right? If all I'm ever is a pattern recognition engine, then where does my identity live? Where does your identity live if you're just like recognizing patterns? Because all you're doing is you're taking in your input and you're matching it to a pattern that exists, and maybe it's changing and it's coming out, right? But somehow we have this impression that we are born with identity, that we are like born with a personality. And in fact, if you Google that, there's a lot of neuroscientists who believe that there are like genetic markers of personality. This person was born shy. This person was born extroverted, right? Now, there's another body of research called attachment research that maybe gives us a hint as to why that might not be true, okay? So attachment is about how infants form attachments to their caregivers, okay? It's based on some research called the infant strange situation. It's basically about making kids cry. Yay, science. Scientists are monsters, man. So what they do, I have an infant right now. My daughter was born about 5 months ago. She's great. I'm doing a lot of science on her. But the infant strange situation, you take an infant and you put it in the room with a caregiver and a control. One of the researchers is there, right? And then there's a bunch of toys around, and the infant plays with all the toys, and then they both leave. And then the researcher comes back, and they're kind of the control, and then they leave. And then the parent comes back, and then we see how the infant responds, okay? And we find that generally infants respond in 4 different categories. There's secure attachment. And again, this is not a securely attaching infant. This is how the infant attaches to that caregiver, okay? My children, I hope, have secure attachments to me, right? If my child is upset, my infant is upset in a room alone, there's some toys there, I walk in and my daughter's crying, she'll come over to me, she'll get soothed, she'll go back to playing with her toys. That's secure attachment, that's what that looks like, right? And that comes from a parent who identifies their child's needs and responds to them. Any of you parents, people have kids in here, some of us, yeah, we've got children about. So you probably were able to guess sometimes, based on the way they cry, what they want, right? My daughter actually probably has distinctive cries for when she wants her diaper changed, or when she wants to eat, or when she's sleepy, or when she just does want attention. She has a very specific one. It's the worst one for when she just wants attention. She goes, eh, and then you look at her and she stops and smiles. You're like, that's not okay. You can't just do that, right? I cannot pay you attention all day long. I got work to do. Secure attachment. Avoidant attachment, right? This is maybe something different about the parent relationship. So an avoidantly attached infant to a caregiver, caregiver comes in, they don't go to them for soothing, right? They're just like, meh, I'm good. Like, I have gone to this person repeatedly for soothing and I didn't get it, right? The parent's misunderstanding the signal, something is wrong. We don't know, okay? Avoidant attachment. Again, these are just 4 categories. I mean, obviously, we all are aiming for, that's only like 20% of this, right? Anxious, anxiously attached infants, they will go to the caregiver, but they won't be soothed easily. It takes them a long time to calm down. They're not trusting that soothing. Then we have disorganized attachment. This one was discovered late in the game, but disorganized attached infants go towards a caregiver and then away from a caregiver and then towards a caregiver and away from a caregiver, and then they'll fall down and they'll start biting their hands on the ground. Disorganized attachment. They're confused about what they're trying to accomplish, right? This might be if you went towards a caregiver for soothing and you instead received terror. And then that's your source of soothing. And so you have a memory of terror from your source of soothing, and you head towards that source for soothing, and then you remember the terror, and then you remember the soothing, and it's a very confusing experience for a child, right? This is the infant strange situation. Turns out that 85% of the time, these are correlated with how our parents treated us. The way that you attached to your parents is likely how you will attach to your infant. If you're one of the 20% who had secure attachment to your parents, that's great. You're going to have infants and they're going to securely attach to you. But that's a terrifying thought for the rest of us, right? For some people who identified with one of those other categories of attachment, that's terrifying. That you're going to pass on your kintsugi brain to your kids through this attachment. And this is maybe why we see genetically correlated personality traits, right? Shy kids from shy parents, and so on. 85% correlation is huge. If you're like 40% in science, that's a paper you can publish, right? 60% is killing it. 85% is just kind of unheard of. Like, doesn't happen very often. So that's kind of a depressing thought. But there's hope. And the hope probably lies in the insula, and it's about intention. And this is all from a book I'm going to show you in a moment, but if I focus on what I want to be as a parent, I can change that. They've shown that you can change that. That parents who have a consistent narrative about themselves, and even about the bad things that have happened to them, maybe you were abused as a child, you experienced some significant trauma, if you're able to work that into the narrative of you, instead of turning away from it. Right? And we all have those things we think about, like as we're falling asleep and we're in silence alone with our own thoughts, and you just think about a scary thing, a terrible thing, maybe a terrible thing you've done. I think about my cousin Connor. Sorry, Connor. I popped a ball that he had when he was an infant. He was like a rubber ball, right? And I like had this needle, and I was like, I wonder how hard it is to put the needle through the ball. Oh, not hard. It's not hard at all. Yeah, I just popped his ball. I still remember that. That's a silly trauma to hold on to for a long time, isn't it? I'm 40 years old. I should probably let that one go. Nope. Brain's got it right there, right? I keep reminding myself. Connor, I think, forgives me probably for popping his ball when he was an infant, even though it was hard for me to get to a place where I was able to forgive myself. And that is a mild example of some of the things that you all have done and seen and been through. You've got some stuff in your brain that you turn away from. You think of a thing and you turn away from it. And I'm here to tell you that that's poisoning you. It's ruining your life, and it's ruining the world. The more we turn away from our anxieties and the darknesses in our own brains, the bigger they become, right? If something reminds me of this instance, let's consider this still a serious source of trauma for me, and I have a fear response to that ball popping. When I see another ball, it reminds me of that. And maybe when I see someone throw something else that is unrelated to a ball, and they tend to grow in the brain, and you have more and more parts of your brain that make you fearful and afraid. You have to walk right into that fire to get rid of it, because I promise when you say that thing to a therapist or to a trusted friend, it's going to get better. And the second time you say it, I'm going to teach you how to do that. But there is hope for you, okay? Your attachment pattern with your parent is not necessarily binding you for the rest of your life. So we're going to talk about memory a little bit. This is Dr. Daniel Siegel. He is the researcher I showed in the beginning, the neuroscientist I showed in the beginning. He's also the person who gave me that attachment information. He wrote a book called Mindsight. He's got another book that plays off of a lot of the concepts from this called The Neurobiology of We, that I definitely recommend. I think every human on earth should listen. It's an audio book only. Listen to this audio book, The Neurobiology of We. But Mindsight gives you a lot of the same information if books are more comfortable for you. I once tried to encourage a friend to get that audio book, and they were like, no, I don't want the audio book. I don't want the audio book. And I was like kind of digging on it because that's what I do. I'm a curious person. I'm like, no, it's totally fine. It's good audio. I don't really do audio books. My friend eventually kind of like broke down a little bit. It was like, listen, like I dated someone a long time ago who was really into podcasting and audiobooks, and they were a monster. I just don't do it anymore. It's a trauma that that person is turning away from for the rest of their life. You may have minor iterations of that in your brain by comparison. This is a real thing. There's traumas and anxiety in your brain. So we'll talk about implicit and explicit memory right now, okay? If I ask you to remember a thing, like what you did yesterday, what you had for breakfast this morning, these are episodic memories. These are things that you wrote down and you can recall, okay? And then there's a different way to store memory. So that's an explicit memory. There's an implicit memory sometimes. There's things that you just can't remember, but you can still do, right? How do you catch a ball? Anyone want to explain how to catch a ball? You move your hand. I mean, you can come up with an instruction set, but you can't really tell me how to catch a ball, right? So implicit memory sometimes occurs when we don't want it to, okay? This is not necessarily unconscious, okay? These are memories like as though you were uploading your episodic memory to the cloud. You're putting your videos up on Vimeo and you forgot to tag this video, so it's real hard to find again. It's not impossible, it's just real hard. And they come back for some people. People who have PTSD, for example, right? So PTSD people, we have flashbacks. We've all heard of flashbacks, right? In his book, Dr. Siegel describes a patient and like crawling under a bed with the patient, and they've got broomsticks and they're pretending they're rifles suddenly, and this person is in that moment, okay? They aren't able to tell it's the past. They don't know that it's not happening right now. They've added the doctor to this memory, and they've added these broomsticks as rifles. They're meshing the two together, but they don't know that they are not living it right now, that you're not living that trauma and anxiety in this moment. So PTSD, we talk a lot about PTSD. Oh, I've got PTSD about that. I've got PTSD like this, like OCD, right? This is a pretty serious disorder, pretty serious stress disorder. There's a certain percentage of the population who are especially susceptible to PTSD, and those are children who were abused over a long period of time. And I mean, they can get PTSD from watching 9/11 happen on TV, right? A huge portion of the country, maybe 20% of the people in the country, got PTSD from watching on television that horrific act unfold. So be cautious about talking about that, but it's a stress disorder, right? This is norepinephrine. That's what norepinephrine looks like. And this is epinephrine, and this is cortisol. And these are stress hormones. Stress hormones inside your body have a very interesting effect. When you get stressed out, when you build out too much of this, your hippocampus turns off. Remember your seahorses? Seahorses are kind of sensitive. They actually, like, they swim really slowly in the oceans, and they're on threatened lists now and stuff. We're killing them off because we're heating up the oceans and adding chemicals and things they're not used to. Your hippocampus is real sensitive to stress hormones. Adding stress hormones to your system is able to disable your hippocampus. The hippocampus plays a pretty crucial role in memory formation in that that's the tagger. That's the thing that puts the tags on your episodic memories as they're recorded into your explicit memory. If you're missing the tagger, guess where they go? They go into implicit memory, and you don't know they're there. And yet you act on them. You're still firing that set of neurons, right? You just don't know that it's a memory even. They're still bubbling back up. It's a terrifying idea, isn't it? And PTSD is one thing, right? But that's an unresolved trauma. And that applies to all sorts of things, right? Even the smallest of anxieties, even this ball story that I told, that's clearly not PTSD, right? The thing that I remember, right? If I didn't actually have that recorded, if I was real stressed out in that moment, real stressed out, like having a fight or flight fear response, I maybe wouldn't remember that I did that thing, but I would hate balls forever. I probably wouldn't have ever played football or baseball, right? And I wouldn't know why. I would just think, this is who I am, right? Defines my identity. All my trauma defines me. Who's excited about that idea? About being defined by your anxiety and your trauma? Not me, right? Anxiety is just a smaller form, maybe, a lesser form of PTSD. You develop these anxieties and they grow like zits in your brain and they make other things make you anxious. And people who have anxiety disorders, their brains become dominated by this. And that forces us into a mode where we become creatures of habit, right? We can't look at a thing, so we try not to go near it by forming habits and following along our habits. And there are some people who are so bound up by anxiety that they will likely never escape. And my goal is for none of you to be that person. Let's talk about the fight or flight response. This is a thing we all learned about. Encountering a stressful situation, we either fight it or we run away, right? I posit that we actually run away most of the time, given the option. I think fighting happens when you're cornered, mostly, right? Given the option, I would choose to flee from conflict. Generally, I'm not trying to have any fist fights I don't need to have. That doesn't sound fun to me. And some people are. Some people get wired into a fight mode, you know. Maybe they got hit a lot when they were a kid. This is how they express power and control now, right? You never really know what's going on in other people's brains. I would ask that you have compassion for them and realize that they're probably channeling some biases and some attachment disorders and some stress disorders and some memories that they don't even know about that came from their great-great-great-grandpa. When another person meets you and they get angry, right? Maybe because you remind them of their drunk uncle, their alcoholic uncle who punched them one time. I don't know that I remind you of your alcoholic uncle. You're just mean to me for no reason, right? And I'm like, well, fine, I'll be mean to you. I don't know why the hate is coming, but I'm going to give the hate right back. Try real hard not to do that. Try to break that habit. Try to have compassion for your fellow human beings. Even Hitler thought he was doing right by the world, genuinely, right? The quintessential example of monster, right? That man believed he was doing the right thing. Babies are not born with malice. I want you to introduce me to an infant that hates, right? Even if you have a sociopathic scaffold, they've shown that sociopaths, people who have the same genetic markers for sociopathy raised in loving, caring families, they don't become sociopaths. They don't do the things that sociopaths do, okay? There's your scaffold, and then there's your mind, and those are separate. You are not genetically predestined to be anything, okay? People who are acting towards you with malice and anger, they don't know you, especially not like you know yourself. They cannot possibly know what they're even looking at, that they're angry. Think about where that comes from, and then think about whether or not it's their fault and whether or not they deserve more hate for it. So, imagine you're a gazelle. You're out here in the Serengeti and you're just chilling, right? You see this lion, right? You probably just see like part of an ear and an eye coming out of the pattern fires. You're like, fight or flight, right? You're out on the open territory, you probably run, okay? There's another response that we don't hear about very often, which is freeze. You remember our disorganized attachment infants? The ones who are going back and forth? They don't really know what to do. They just kind of stop. Just kind of freeze there, and then they get eaten, okay? Freeze is not an ideal response from an evolutionary perspective. But freeze we don't talk about. I think we mostly flee or we freeze. We're still trying to decide. There's a lot of evidence to suggest that when you decide a thing, deciding a thing all in is really important. Deciding a thing 100%, like entrepreneurship, we all know this story, like 9 out of 10 new businesses fail, right? 90% of a particular subset succeed. And those are the entrepreneurs who literally walked off a cliff. They had no option but to succeed, right? They cashed out their 401k, they were destitute, whatever it was, those people tend to succeed. Willpower. I'm going to talk briefly about willpower and convince you that having these anxieties in your brains matters, okay? This is a little illustration from a famous experiment done on willpower where they had some people sit in a room with some fresh baked cookies that smelled like another baked goods, smelled like fresh baked cookies, and they were like, do not eat the cookies, right? You can't have the cookies. In the other group, they sit in a room with some radishes, right? You know, the cookie group, they can eat, the group that's in there that is told they can't eat the cookies, they can eat as many radishes as they want. So they're sitting there looking at cookies. Some of them are holding the cookies longingly, right? Scientists are monsters. Again, they're sniffing the delicious cookies and putting them down and eating their radishes, sadly. The other group gets to eat all the stuff they want, right? This is about willpower. This is about resisting the urge to eat the cookie, even though you got the radishes. It's not about caloric intake, right? And so what they found is that they would take the people out of this room then afterwards, and they would sit them down with a labyrinth. And because scientists are monsters, the labyrinth was unsolvable, as it turns out. The group who had to resist eating the cookies, they tried on average half as long as the other group. They depleted their willpower by 50% in about 15 minutes. So remember we were talking about order of complexity in brain operations? Your brain burns about 20% of the calories you take in. It's 2% of your body. It's a very expensive resource. When we go from 1 cycle to 2 cycles, that's a big deal, right? If you're just trying to go about your day and you're accidentally reminded of an anxiety, your willpower just chunks down. Chunk, 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 right? Negative self-talk, me stubbing my toe and saying, you're an idiot for stubbing your toe. Of course I'm not an idiot. People stub their toes, right? This does the same thing. I talk about this with my kids. It's like you start your day with a bucket of willpower tokens. And every time that you say a mean thing to yourself, you're just throwing them on the ground for no reason. And your brain is learning. Every neuron in your body is learning all the time. Why would you do that to yourself? Don't do that to yourself. You're remembering, and you're remembering out of context in ways you can't stop. This is how people back themselves into a corner in their brains and sometimes commit suicide about it. And what they really need is to talk about those fears and those anxieties that they have inside, to share them with another human being who can be like, that's ridiculous. You're not an idiot for stubbing your toe. They can compare their perception, get relative perception. No man is an island, right? This is one of my favorite songs growing up. I am a rock, I am an island. I love the idea that I can just do it all myself, right? Not true. We need other people. So how do we solve this problem? We've got all these anxieties and things, these bad habits in our brain. How do we fix it? We fix it, according to Dr. Siegel, via integration, okay? We try and integrate those with other things. Let's take the negative self-talk example. If I catch myself during the day saying, I'm an idiot, and even just saying it now, I've now said it like 3 or 4 times in this presentation, I'm creating a pathway, right? I'm brilliant, I'm smart, right? I'm doing a good job here, my presentation today. I'm very pleased with myself. It seems to be going well so far. I'm recording a new memory, okay? And I'm attaching it to that experience. You say a negative thing, say 2 positive things. Attach it to something else. This is the same way therapists fix you when things are broken. This is a map of emotions and all the emotions that we have. And it's not even, there are people building bigger maps of all this. This has words on it, so I'm going to skip ahead. Here's a new map of emotion, okay? Fear and joy. Just think about these 2 instead, okay? I kind of feel like most of your emotions, they're either fear or joy. There's the good ones and there's the bad ones. And the good ones are actually just kind of the absence of the bad ones, if you think about it, right? When I get angry at someone in traffic and I'm like, oh, you cut me off, I'm not actually angry at that person. I don't know that person. I've never spoken a word to that person. I'm afraid that I live in a society where it's okay for them to have this unjust behavior that endangers me and my children. I'm afraid underneath. The degree to which you are able to address the underlying reasons for your negative emotions is the degree to which you are able to heal yourself, okay? When you get angry or upset about a thing, sometimes this happens to us when you're reading, and you're like reading through a paragraph and you have to reread the paragraph, and you have to reread the paragraph, you have to reread the paragraph. It's because something in there is throwing you off. Your brain is skipping a beat. There's some anxiety or some trauma or some stressful something in there. Sure, it's not always the case, right? Sometimes it's just too difficult to understand until you loop a couple times, whatever it is. But usually these things pop up in ways that we can't see, right? They're unresolved traumas. I have some strategies at the end for finding your own unresolved problems and helping to heal them. One of the things that really matters is compassion, right? This is Dr. Siegel meeting the Dalai Lama. It's about intentionality, about coming to yourself with love. That thing that we did, that little exercise at the beginning, I did actually tell you the secret to happiness. That's it. That's it in its entirety, okay? Everybody knows the Dalai Lama meditates probably a lot, right? A lot of people who meditate, they talk about compassion, that all that you have to learn is how to love other people and you'll be happy. And that's really it. Love yourself, love other people, you'll be happy. This is where happiness comes from, is compassion. And Dr. Siegel extends this to a field called interpersonal neurobiology, which he invented and is now a thing and a lot of people study. And interpersonal neurobiology talks a lot about how our neurons affect other neurons. So remember we were talking about electrical signals and chemical signals? Now, when I'm saying words, they're traveling through the air and they're perceived by a little bone in your ear and it's knocking against another bone and then you hear things, right? But it's just an electrical signal, again. Consider it a very slow API for me interacting with your brain. Right now, as I'm giving you this talk, we are communicating almost telepathically, as close as we can get for human beings. I'm asking you to meet me here so I can share some ideas with you, right? I'm integrating you into my system, and we together are integrated as a system. And I have an individual relationship with you and you and you and you and you and you and all of us, but then we each have those with each other, and then we have a relationship as a group and as subgroups. If you have 2 people, they have a relationship with each other. If 3 people, you got these, and then this one, it goes much more complex, right? Much more integrated. But the addition of all of those perceptions gives us new perspective in every moment. Mirror neurons are neurons that fire in your brain. When I eat a peanut in front of a rhesus monkey, the rhesus monkey's neurons in their brain, they fire as though they were eating a peanut. So by seeing a thing, if I start crying right now, you may not cry outwardly, but your brain's a little crying. You'll start to empathize with me. You'll feel kind of sad. We've been talking about some real depressing stuff, right? Also some real hopeful stuff if you think about it. This is happy stuff. See the happy face in the mirror? Okay? Mirror neurons mean that I'm actually empathizing with you on a deeper level. This is how human beings develop empathy. That's what empathy is. It's about having compassion for yourself, forgiving other people for their indiscretions, assuming goodwill in other human beings, so that your mind is able to function on a level where you connect with this interface. Because if you don't trust another person, that just doesn't work. Okay? You don't open yourself up and let that in. Perception, rose-colored glasses, right? So let's say that I have a particular set of patterns in my head, and those color my perception all the time. I've got red glasses on, right? My friend Nate, he wears blue glasses. I can't know his brain inside and out. He's got a different perception than me, though, just like saccades, right? We've never seen the same thing from the same angle ever, right? Other human beings have different perspectives than you do, always. Your brain is only able to see red if you've got the red glasses on. I can't see myself honestly, but I can see myself honestly through his perception. This is why human beings are binary stars. That's why we require other people. This is why single founders fail way more often than co-founders do in entrepreneurship, way more often. You can't be honest with yourself. Sometimes it takes another person. Here's some advice for you. Exercise. We're going to go into the advice portion of this presentation. It's been a nice long time. I can see all of your eyes glazing over. Exercise. It's a real easy piece of advice to say, right? It's really hard to do. Like a lot of us have a hard time motivating ourselves to exercise. Someday I'm going to be real motivated. I'm going to wake up and I'll be like, today I'm going to exercise. No, that's not true. Because my brain heads towards certainty, right? And complacency, right? You imagine your habits forming, your memories forming, your patterns forming as like me skiing down a hill and burning tracks into the snow. And then there's the laying tracks down in the snow. And then the next time I go down, I'm likely to go down the same thing. Caught in a rut. It's the thing we say often, right? You get caught in a rut about everything. You're never going to wake up and just decide to exercise. It's not a thing. You got to force yourself to do that thing. You need to focus your attention on doing that thing. Maybe using the awareness and attentional capabilities of your insula. Right? Insula is probably pretty important for this. That's why it fires with everything that we have. Every time we think a thing or do a thing or experience a thing, your insula is firing probably because that's your attentional capacity, maybe. So exercise, and I have some easier advice for you. I just want you to look up these things. HIIT and Tabata. Anyone know what these are? High intensity interval training and Tabata. These are anaerobic forms of aerobic exercise. So like, that's a weird thing to say, right? But it's really intense exercise for a very short period of time. A lot of people's complaint about exercising is I don't have time, right? If you don't have time to exercise, look these things up. This is a 5-minute workout. Do Tabata exercises. They're timed. You do it as hard as you can for a period of time, and then you take a break, a little slower. And you do it as hard as you can, and in 5 minutes, you're done with a workout that gets you greater gains than you would have if you did your 30 minutes a day, 3 times a week thing that everyone recommends, okay? Just do 5 minutes a day instead. Get up in the morning, do some exercise. Doesn't really matter what it is. You move, you increase the capacity of the resources to move around in your body. That makes intuitive sense to people, I think, right? Just like our breathing exercise, we're evening out the oxygen we receive. You even out all of the other systems in your body by exercising. It's a really good idea to exercise. It will make you smarter. If I were offering you a pill right now that would make you 20% smarter, I bet you would pay me money for that pill. I gave you most of it already. It's $100 a piece, by the way. I'd take cash or check, okay? Here's another bit, diet. Oh, you're gonna tell me how to eat? Not really, actually, because it's really complicated to talk to people about, right? You're gonna decide what you eat. But I think you know what is bad for you to eat, right? Flamin' hot Cheetos are a good example. What does that do nutritionally for your body? You're probably gonna eat them anyway. But be conscious of when you eat. Anytime you put anything in your body, think about it. Think hard about it. Pay attention to the things going in your body. Sometimes when I'm anxious, not many of you maybe have known me for a very long time, but when I gave this presentation originally 6 years ago, I weighed about 135 pounds more than I do right now, right? And I didn't lose weight because I beat myself up about it and I was real sad. I lost weight because I let go of my feelings a little bit. I stopped eating my feelings. I got rid of some anxieties in my life. I started to realize that when I got upset, when I had a difficult conversation with my wife, suddenly I was standing in the pantry and I wasn't even thinking about it. It's just a habit that you develop. Eat intentionally, chew slowly, pay attention to the bites, skip up your walking, brush your teeth with the wrong hand, break up your habits, break up your habit with your diet. Also, if you want some advice on what to eat astaxanthin. It's in salmon. This is why I chose salmon. Astaxanthin is really cool. It has neuroprotective effects. It's a very powerful antioxidant. Vitamin C is the one we knew about before astaxanthin. Astaxanthin is like 5,000 times as effective for antioxidant properties. It's anti-inflammatory, neuroprotective. There are a lot of bits of research about it. You can get it at Costco in little pills and take it. It's also in salmon, anything that is pink, like shrimp. It comes from the algae and stuff that they eat. So if you're not a big fan of like eating handfuls of algae for breakfast, you might look into animals who eat astaxanthin and become pink, or maybe take a supplement. Habits, breaking the habits. Break the habits that you've built into your own mind. Brush your teeth differently, walk differently, perceive others differently, put other people around you who see the world differently. Go and follow some people of color on Twitter. If you are not a person of color, that's an excellent way to broaden your perspective. Don't shut these people out. Go follow the Republicans if you're not a Republican, okay? I'm most definitely not, okay? I don't identify with the methodology, right? But I try to listen. I try really hard to listen. I try to meet people where they are, because that's how we're going to heal the planet. This is a real problem for us, that we are willing to just let our anxieties box us up and live as creatures of habits. This may end the world. It's a very serious problem. That's how wars start. I don't want any more wars. So break your habits. Get therapy right now, for always. We have one person who's normal in here. The rest of you, you had your chance to be normal. You can't claim, oh, I don't need therapy, I'm normal now. I want to tell you something about therapy. This is actually, it's not what you think it is, right? It's not to fix the broken parts, okay? It's maybe to fix the broken parts of that bowl, to put the gold in the cracks, to make you a more whole person. Addressing your unresolved trauma yourself is a very difficult thing because it's unresolved and you can't tag it or remember it. How do you find those things? How do you address your own anxieties if it's impossible to see them with your red glasses? You can't. You need other people. Doesn't necessarily have to be a therapist. But your favorite video game, when you got that +1 stats item, that felt awesome, right? +1 to every one of your stats. That's what therapy is. And I get that it's also very expensive. Unfortunately, we limit the access to this +1 all stats item to the very upper echelon of society. That's real messed up, in my opinion. Reagan decided that mental health care wasn't a thing anymore. We're just going to kick all the people out of the mental institutions, let them die on the streets. That's a pretty messed up idea, in my opinion. I think humans deserve access to mental health care, all of them. Therapy is a real good way to get it, but if you don't have access, I have a couple strategies for you, because you can actually do a couple things all by yourself. One of them is EMDR. Anyone ever heard of this? Eye movement desensitization and reprocessing, EMDR. I had to go and look this up because I've known what EMDR was for a long time, but I didn't know this eye movement desensitization and reprocessing. We don't actually know very well how this works, but it might work because it occupies part of your mind. so that you can address a trauma without having the trauma response in your body, okay? Because when you get stressed out, very specific physiological things happen to you. Your gut shuts down, because like when that gazelle sees the lion in the field, you need to prime the legs to run. You shut down salivation, your mouth gets dry, your heart starts to beat faster, you're getting ready. Your body is primed for action, right? That's that stress response. It can overwhelm you. If you're addressing your own traumas and anxieties yourself, it can overwhelm you. You'll have a panic attack. Some of these things are too stressful for us to handle on our own. This is one of the strategies we have. This is how they treat people with PTSD. You move a finger in front of their face back and forth like this. And just have them tell you a story about a really scary thing for them. And you can do it to yourself. It's maybe not quite as effective. Maybe it's about half as effective, but you can do this to yourself. When you think of something scary or something stressful, or you turn away from some idea that you just can't tolerate, go and sit down and focus on your finger, move it back and forth. And just look at that and tell the story to yourself in your head and integrate it. Integrate it with something happier, okay? If I was raised in a real abusive household, that probably affected my character as an adult. If I love myself, then I have to accept that that was part of who I am. That made me who I am now. I don't have to accept that every time I think about my uncle punching me, right, that I'm just going to have this trauma and I'm going to turn away from it. No, I'm going to integrate it into my story. And that's how people overcome those lines of attachment where they pass down attachment disorders to their children. They overcome that by integrating their own unresolved traumas and anxieties into their own lives. Okay? EMDR can help with that. Before EMDR, we had CBT, cognitive behavioral therapy. Keep a journal about things you feel. Write down the things that are scary to you. You don't have to show anybody. Get a field notes, little binder deal. These are from Portland, by the way. Field notes was invented down there. Cool designer, spoke at TEDx one time. But get a little field notes. I've got some in my pocket right here. I write down my emotions throughout the day and when I felt things. Not for anyone to see but me. Just review them. I don't even review the notes that often, right? I just write down if I think a thing that's real scary or traumatic, or I am feeling a certain way at a certain time unexpectedly. Like, why did I get so anxious right then? That's weird. I just take a quick note about what was going on, and eventually you go back and address those things. This is the kind of thing that you would do in CBT, in cognitive behavioral therapy, with the guidance of a therapist. You would be taking notes and making maps of the things in your brain and trying to understand how things fit together and how you can integrate them back into your life. Sleep. That's a short one. Just sleep. Actually sleep. For some reason, this is a badge of honor in our society, in the startup community especially. I only slept 4 hours a night for years. Iron Man sleeping, whatever it is, you make up some thing so that you don't just sleep for 8 hours every day. You just need it. It may feel like wasted time, but you're wasting plenty of other time walking around with your anxieties. You cement your memories, you heal your traumas, you do all sorts of good things for your brain. This is the cleanup step. If you like garbage collectors in your language, you will like sleep. Who wants to use language without a garbage? Just never cleans up. Just bloatware, just spill the hard, yeah, right? Like, that's ridiculous. Nobody wants that. Sleep. It's your cleanup step. You need it every night, probably 8 hours. You need more when you're younger and less when you're older, and you get a little bit less when you're older, and blah, blah, blah. Just sleep for 8 hours every night. Set a bedtime for yourself. Barring unusual circumstances, I will go to bed at midnight, and I will try to be up out of bed at 8 a.m., and I may not feel like getting up, but I never hit snooze. I'm intentional. I stand up whether I feel like it or not, and I say, good morning. What are we going to get done today, right? Ask yourself questions like that, like, how is today going to be awesome? Frame things positively. Think positive thoughts, right? Don't wake up in the morning and be like, oh, I'm so tired, today's going to suck. Because your day will suck, obviously, because you just told yourself it would, and it's self-reinforcing. Other strategies for getting good sleep, weighted blankets. No science to support this at all, but weighted blankets totally work. I have one, I love it. It's like sleeping with a hug. I sleep straight through the night and never even wake up. It's amazing, right? I already told you I'm an old man. I woke up several times a night before I got a weighted blanket. This is a real hard thing to test because you can't really do a control, right? You're like, this blanket is real heavy. Pretend it's heavy. Like, you can't really do a blind study with blankets because people know when they have a heavy blanket on them. It'll help. It will. It worked for me, but there's not a whole lot of science to support it, but a lot of people are using them and loving them. Try sleeping with a hug on you. They use them for autistic children and people with other developmental disorders for a long time. Weighted blankets and like hugging machines. They had machines that would like close on you to make you sleep. The thing that reminds you of being in utero, it's a very comforting thing for an infant to swaddle an infant. Turns out we're just big infants. I don't know if anyone knew that. About yourself. Give yourself a hug while you sleep. One more bit of advice to cool off. This is a weird bit of advice, actually. There is some science to suggest that cooling your forehead to between 67 and 71 degrees will make you sleep better. If you're the kind of person when you're falling asleep where your mind starts to race and you have what's racing mind or racing thoughts as you're trying to get to sleep and it's difficult for you to fall asleep, it may help to cool down the room. Or either put a little ice pack on your forehead for a little while. You know, not too cold, put a little towel between it, so, you know, freeze your head off. This is a machine, it's called an Ebb sleep device. I talked my doctor into letting me try one of these the other day. It's a prescription device. If you could talk your doctor into letting you order one of these things, pretty cool idea. It sends a coolant in that little blue jug over your phone. I'm totally gonna do this and I will report back my findings as to how much better I sleep. I'm all about hacking my sleep to be better. Sleep's a really important step for your mind. Do whatever you can to make sure you're getting as much sleep as possible. Cool off your brain if you have to. This is the best advice I can give you. Meditate. Yes, every day. Yes, for half an hour. Spend the first half hour of your day sitting there doing nothing. Well, I don't know how to meditate. I've never been to meditation school. No, you did already. You remember that exercise we did? That was it. That's all of it. That's mindful meditation. There are a lot of other forms of meditation. There's like ones where you dance around and you got to chant and all this stuff. It's associated with religion. People have been doing this for a long time, but they didn't really know what they were doing. But some people got it very, very right, accidentally. It's about focusing on yourself with compassion and love and paying attention closely. This is Dr. Sarah Lazar, researcher at Harvard, did a study of some lifelong meditators. They found that the insula in their brain was thicker. The cortical thickness of your insula, your attention organ, was thicker in people who are happy like as a career. So maybe think about that. Maybe now think about meditating again. Knowing that your brain physically changes. You become better at paying attention to things. You become a happier person if you meditate. And you got to do it with that intentionality we talked about, that compassion and love for yourself and for the world. Breathe in the love, all the love you've ever known, and breathe out all the yuck. Breathe in the love and breathe out the yuck. Compassion for yourself and for others. You are not your brain. You're not. You've never been your brain. Your mind sits atop your brain. You're not your parents. You are not your trauma. You are not your anxiety. You are what you decide to be right now in this moment. And if you come at yourself with love and compassion, you can heal the world. Thank you.